You put one to not start up.
For some reason, it's still not working.
Okay.
Same as Riley.
Hey,
So I have some quick advice on something that I imagine some other students may have thought about as well.
what's that?
Something I decided to do was set up a GitHub repository for the SQL projects. So that I can easily access it from home and from here.
That's a super idea, and I would like to actually have you guys submit to GitHub your assignments. And I mean, I'm trying to figure out a way, you know, to do some auto grading. So that's perfect. I think that's a really
great.
good idea.
That
Now,
I-
whenever
I have
you
asked my question.
save in SQL Server Management Studio, you save their queries. They're going to be a .SQL file. If you look at SQL Server Management Studio, you can create a project to kind of keep those things together by chapter if you like.
I wasn't done yet.
Oh, sorry.
You said there was issues with the C drive and the H drive and all of that, and I'm wondering where would be what is the right place on this network to save this version of the
Just to your H drive.
Okay.
Or, well, actually, I guess your H drive is going away, so with OneDrive.
On
your
the
document.
OneDrive is fine then?
Yeah.
Okay.
Yeah. And since they're just Word documents, it should be pretty flexible with you. But I would not save that Word document to GitHub. I would just save your query, because that's the actual.
Yeah, that's the part I need to actually work with.
Yeah. So that's the source code that you would want to save to GitHub. Great idea. If you guys are on GitHub, make sure you think about doing that. Because whenever we save from SQL Server Management Studio, we're just saving to the file system. It doesn't like save it itself someplace. So you'd still be able to get to it from your OneDrive from home if you save it that way. Last time we were just looking at select statements and you guys took off and we're doing great looking at them. And I just wanted to talk about some of the things that we can do to further enhance the basic select statement to do even more for us. So we saw last time that this statement starts out with the keyword select. The next thing that we want to list is a list of columns. Now this database diagram that I gave you today, this entity relationship diagram, includes tables from both our AP database that we created and the My Guitar Shop database. So basically in our implementation, we put all of these tables in one database. Doesn't matter because the database itself is just like an organization container. The tables are what's important. It's the data and the table definitions. So this database diagram or entity relationship diagram shows all of the tables in both of those databases. So this should cover both the examples given in the book and the assignments that you have for at home. All of the tables should be available within your database. Now this picture shows us for each of the tables what all columns we have. So looking at this diagram, especially when we first start working with a new database, is super important. It is. I'm not sharing. It's zooming, but I'm probably not sharing. So I'm just talking, but it's not much stuff. All right, thank you. So if I were at a company and I was assigned responsibilities for working with something that involved a new database, I would ask if there were a database diagram available so that I could start getting familiar with the tables and relationships in that database, all those tables. So when we format our column list, we can use any of the columns from any of these tables in our database to list in that column list. But we can do other things too. So besides just listing table columns, we can do math expressions. We can do some string manipulation, like adding strings together, doing some concatenation. And we can call SQL functions. So just like we would have a function or a method in C# or Java that we could call to do some sort of calculation or something, we can call functions in our query. Now we saw last time that the asterisk is used to select all columns in a table. So that's pretty handy. And oftentimes people will just do, like they have their select star, and then they'll add the table name. Now we saw last time that list of columns I wanted to get into some of these more advanced things. Now this example shows where we're going to select the invoice number, but then we want to do a calculation, and we're going to call the result of that calculation, the answer, balance due. So our output is going to list the invoice number and the balance due. Let's try that one on SQL Server Management Studio so you can see the output. So I have it open, and I want to create a new query. Let me zoom in a little bit. I want to use my database. Whoops. Go down. Pressing enter wouldn't make it go to a new line. Now it is. Just the greatest tool ever. All right, so now once I've got my database set up, I want to do this select statement. And we wanted to get the invoice number, and then I do a comma because I always put a comma after each of my items in my column list. And then they want us to just do this calculation. Now notice they have it on the next line and they have it indented, and that's a coding standard. So we normally have the select statement, you know, over to the far left border, and then we'll indent lines of code underneath that select statement. So I want to do a calculation where I'm going to take the invoice total, this is the total of our bill, minus our payment total, how many payments we've made, minus our credit total. And this is like, credit is like some sort of thing that we don't owe the vendor apparently, because they always put that in every calculation. And we're going to call this as balance due. Now I wanted to run this query together because throughout our whole semester, they'll use this formula over and over and over, is the balance due. So this is the first time we'll see it, but you'll see it a lot. So just so you're aware, this is the formula that, you know, maybe our accounting department said, this is what I want you to use to get the balance due. So now I can execute that query. Oh yeah, what am I missing? The from. So where do we want to get this from? If we look at our database diagram, what table has all of these things? This is kind of, yeah, this is kind of backwards. Say from invoices. And that should be better. Now, if you look, we don't owe very many. So a lot of these bills we've had, we've already paid. How could we make it, how could we add to this query to where we only see the ones that we owe something on? Where? Exactly. I'm trying to move this down a little bit. So I'm going to add that. I want to say where. At this point, can we access this balance due that we just kind of created, where balance due is greater than 0? Nope. So even though we said we want to call the result of this formula this name, that didn't really create a variable or anything like that for us to use. That's just a temporary thing only for that column. So if we want to include that criteria in our where clause, we have to repeat this formula. So I'm going to put it down here in my where clause also. It's kind of redundant, but as we learn things, we'll figure out a way to get away from that. But that's why we'll type that formula so many times. Okay, let's see if that will give us just the ones that have an outstanding balance. I'm going to execute it. Now, is everybody being able to run that okay? Is that working okay on your, what you have?
Yeah.
It's okay. It's working? All good? You've got data, getting stuff out? Yay! right, so now we see some calculated things. There we go. Okay, so we could do that calculation. The next example, and this is a PowerPoint, it's like page 12, those slides. I'm just looking at it in my OneNote document. Now this next example shows concatenation of two strings for a column. So here we're saying we want to add the first name, a space, and the last name together, and we're going to call that full name. So that would be a string for us, concatenation that we can use. Notice that they use single quotes. And then in this example, we're actually calling a function, the function name getDate. And we're going to call the result from that call current date. So we'll get a lot of practice doing those things. Let's take a look at some of the other options. Now, this one on page 13 is the first time we'll see where we have a lot of different options of syntax. And this is something that can get you, W3 Schools, I know a lot of you guys use it for your web dev class. It's got some great information. W3 Schools does have SQL stuff. Let's stop and take a look. I'm gonna jump over there. Bless you.
And Google tried to predict that I did in fact want to look at SQL stuff there when I typed it in.
Did it take you there?
No, like Google, when you start typing your search into it, it gives down suggestions for what it thinks you might try and be completing.
Where you want to go?
I got to W3 Schools and it suggested, oh, are you looking for W3 Schools SQL? Like,
It knew you. So there is down here, right under server side, it says Learn SQL. So they do have a tutorial. And it really goes along pretty closely with what our textbook does, of course, because it starts out with basic select statements. And then just like it'll give you all of the syntax for all the different HTML code on W3 Schools, they have a lot of the different SQL syntax right here. So it's really, really helpful. You can execute the examples online. So you can just try it, you know, and see. It takes you into your own little kind of SQL server window so that you can run things and you can make changes to the SQL code.
I love the names.
Yeah.
Like, I love the around.
It's so hard to make names. It really is.
Friends restaurant or restaurant.
Eastern Connection.
Laughing back us wine sellers.
The Hungry Owl Grocer.
There's some great ones.
Grocers actually sounds like a grocery store. I would totally run a grocery store name.
You would go there. So W3 Schools is a pretty good source. I bring that up with this slide because this is the first time they talk about an older technique. SQL has been around for a little while. And as it has evolved, some things have changed and people have said, well, I would prefer to use this type of syntax over this type. And I mentioned that the very first time we started entering SQL syntax. I never worked at a place that used this uppercase standard because that's kind of a newer thing. So they give you the preferred technique and then an older technique. Why? Because when you get out in the field, you're going to see some of these older things in use. And they want you to be aware that this exists and you might run into it. But in general, we want to use the newer preferred technique. So let's look at this one. In this case, we're using the as keyword to name our columns. I have a question. Why do you think this invoice number column name is within square brackets?
I had a question not related to that.
I noticed that you can't have multiple words in the ads section of the query without those brackets.
So that's exactly right. Because invoice number has a space in it, and that's how we want that to display, we have to enclose it within the square brackets. So anytime we use an illegal variable name like that in SQL, we enclose it within the square brackets. So we call it kind of an illegal variable name. SQL will allow it. It's just that it has to be within the square brackets to show the beginning and end of that desired amount. Now, the older technique was we would say select, then the name we wanted to call it, and use the equal sign to specify the fields. You can tell this syntax is much less confusing, much clearer. So we definitely would want to stick with that up there. But that's why we have the square brackets.
The detail I'm noticing is the little semicolon. Am I correct in assuming that indicates the end of a line of code here?
It does.
Like it does.
And if you've noticed in Management Studio, we've been able to leave those out. So it's kind of an optional thing when we're working online with the SQL Server Management Studio. But if we were sending this SQL from a C# program, from a Python program, something like that embedded, that semicolon would be very important. And we'd have a syntax error if we didn't have it. So good point. We'll put those in. Now, what's going on in this one? Anything different than what we did in the query we just entered?
It's not checking their like about.
Right, we took the where clause out. And they're not naming that calculated column. So notice in the result set, it just says no column name up here. Since it was a calculated result, it doesn't know what to call it. So no big deal, that's fine. Concatenating a string, we use the plus sign with strings. It's like a lot of it is very similar to our common programming language code. Here again is formatting a string with spaces in between the different items. In this example, we're gonna add the city, state, and zip code together with spaces in between and call that address. This example shows you how to output an apostrophe. In this example, we have to put the apostrophe we want to output within single quotes. So basically we end up with 3 in a row to get one output. Just gonna skip through a few more here. Okay, doing arithmetic. We saw that we could do arithmetic in our column specification and in our where clause. And that's normally where we would want to do them because we wouldn't do any sort of math in our table specifications. So we have standard arithmetic functions, multiplication, division, modulus, addition, and subtraction. We're used to. Here's our balance due. Okay, so this example is on page 20 of that never-ending presentation. And it shows how you can use parentheses to affect the order of operations, just like any of your good standard programming languages. I'm gonna kind of skip past some of this math because I know you guys will just jump right in there. Okay, so take a look at this select statement. Tell me what that function does. Yes, sir.
It looks like it puts like one column on the left and the other on the other side.
It seems to be ultimately trying to separate first and last names.
You're saying from which side to grab of the values on the left, and then you're grabbing one character, so you're grabbing the first letter of each.
So we're grabbing the first letter of the first name and then concatenating the first letter of the last name and calling that initials. So perfect, you guys are all right on it. We're seeing our new initials column right here. So the left specification is saying I'm going to take data from the left side of this result, and then we're saying how many characters we want of that leftmost data. So we could put a 2 there and get the first 2 letters of their name if we wanted to. Now, we'll be looking in the next few chapters at the different data types that are available with SQL. And we have a lot of different data types, just like in most of our programming languages. And this example shows you that you can do a convert function. So here we're converting our payment date to 8 characters, and then we're converting our payment total to a variable length character with 9 columns allowed. So keep a hold of this example because you might need it for your assignment. Now the next example, page 25, shows additional functions. What do you think that's doing? What's date diff? The age. What are we comparing here? Mm-hmm.
It's saying how long it's been since that invoice has been shipped out.
Very good. So, whoops, I'm going to trip myself there. This date diff function, we're saying we want to know the days of difference between the invoice date and today's date. Very, very good. So just remember these examples are here because sometimes you might need them. Now, some of the terms that they're using in this chapter, function, parameter, and argument, you guys are very familiar with from your programming background. They have the same meaning, the same definition. So we're going to start out with this select statement that gives us all the rows, and we have an order by clause so that it's sorted. And so what's the difference here by adding this distinct keyword?
Only the ones that are different vendor cities and vendor states.
Hear that? Let's try it. So I want to open a new query. I'm going to use my database. Now I want to try putting the semicolon here after that. I don't think I need it after the go, though.
It gets quite upset if you try to put one after the go.
That's what I was thinking.
I think that was supposed to be the start of that statement. You know, it's saying go do A, B, and C. Go.
And then come back and do
select,
this.
And then it's the start of a statement, not the end of it. It's not a statement in and of itself.
Hanging on. Okay, so I'm going to put in this select statement, I'm going to leave the distinct keyword out first and run it. So I want to select the vendor city and vendor state from our vendors table. Remember, these are the people that we owe, and I'm going to run this. And so here are all the different cities and states for all of the different bills we have. And we're like, well, that's not very helpful because I just wanted, you know, to know which cities and states, and this is just too much. So I can add that distinct keyword. Now, it is an SQL verb, so I will type it all in uppercase. And you can kind of tell the words that turn blue if the management studio is working properly are the ones that should be in uppercase because those are our keywords. Now, as soon as I add that distinct keyword, and notice it comes before my column list. Whoops. I clicked on new query instead of execute. I'll run it again, and now I just have distinct stuff. Now, a couple of things about SQL Server Management Studio while we're here looking at it. I don't know why I can't move this down. Move down, move down. I'm going to copy this query. Do this with me, and I'm going to put it down here again. Now, I want this first query to not have the distinct keyword, and I want the second one to have it. In Management Studio, I can control what runs by selecting it. So I can select these 4 lines and execute, and it'll execute that select statement that doesn't have the distinct. Then if I change it and I just select this select statement and run it, it's going to do that distinct. Okay, so we can just like keep adding stuff to the same tab in SQL Server Management Studio and just highlight what you want to run.
Frank, I have a question.
Uh-huh.
What is the appropriate way to leave comments in these bits of SQL?
Yeah, the appropriate way is dash dash, like that. And we'll try to put some comments in, and a lot of people, like when you guys are working on the assignment, if you have the Word document open, a lot of people will copy the question and just paste it here in SQL Server Management Studio and make it a comment, and then that question is right there in front of them the whole time as they do their development, and then you don't have to split back and forth. Other than that, there's not a lot of commenting that happens in SQL.
How do you keep commenting?
Just 2 hyphens, so dash dash. So we'll put some in, but database administrators and people that create select statements are not very good at commenting. And I would, that I would encourage you guys to comment if it were something that was done in the industry, but it's actually in queries. A lot of times they're generated from tools that will generate these select statements. And so it's very common to not to comment at all.
It's a useful way to take notes here, though.
It is very useful. And if you use it like that, like keeping track of what you got and then kind of keep your whole file together, it is really helpful. You can copy and paste that into OneNote if you want to, too, to keep track of everything. Okay, so we can use the Management Studio to kind of help us. So distinct. Distinct means everything being the same. So what if I added something else to my query? I'm going to add vendor ID or vendor name. How about that? That's a little more meaningful to us. And I want to execute then this select statement that I just changed that includes vendor name. I'm going to run it, and I get all of these vendors. Now I want to do the same thing to my distinct. If I add vendor name into that query and run it, I'm going to get the same exact results. Why? Distinct didn't do anything. Why? How could I break it?
Presumably because there's not more than any one copy of any given vendor name.
Exactly.
Really
So
matter.
distinct is going to only combine if the whole set of column names are exactly the same in our select statement.
Something I have noticed is that it doesn't like it if I put distinct on. It wants distinct to be on the first column or whatever it is.
It has to come first.
So
Right.
like on that one that you've got highlighted,
Mhm.
if I try to move that distinct to in front of vendor city, it doesn't like that.
No, it has to come first. It has to come right after the select statement. That's a rule.
Why is that a rule?
That's the rule they made when they made the language. You make a language, you get to make the rule.
We don't know.
That's the rule. I mean, that's the syntax. Just like in C# we have given syntax. This is a SQL syntax. Distinct has to come right after the select keyword. That's when it's expecting to read it. So if it sees it someplace else, it's like, I don't know what this is. It doesn't mean anything to me now. It only means something to me there. So distinct. What about a top clause? In this example, we've again added a special keyword right after the select statement. This time it's the keyword top. And we say top 5. And we're saying we want the top 5 vendor ID invoice total from invoices. It only gave us 5 results. Do you think it gave us the 5 that have the top, the biggest vendor ID, or the biggest invoice totals? So it actually used intelligence a little bit to figure out which column to use as the top column. It was like, oh, the invoice total is a number, So that's the number the column will select from.
Is that because we said order by? Would it have done the vendor ID if we didn't?
Let's try it. That's a good question. Let's try it. I'm going to open a new query and put that in. Top 5 vendor ID invoice total. And that's what's really cool about SQL. It is so easy to just try something. You never have to wonder what it'll do because you can just try it. Put my semicolon in. Now I don't have a use statement because since I have my database open over here, I'm kind of by default using it. But I do like to always put that in for good measure. Whoops. Not the logo. Now let's run it. Okay, so when we put the order by invoice total, it chose the top 5 by invoice total. Let's change our order by to vendor ID. Right now, notice we have a whole bunch of things from vendor 110. And to see how this changes.
Does the little desk there at the end stand for descending by chance?
Uh-huh. Very good. That's descending. And Caleb analyzed that exactly right. Since that order by clause was specifying the invoice total, that's what it used for that top statement.
Could we tell it to order by some columns that we haven't already called for?
Let's try it.
So like, could we order it by the vendor name, for instance?
I'm going to put a comment in here. Use the top statement to pick the top 5. Okay, and we want to order by another column. So let's try in our vendor table. How about vendor city? We're not selecting that. Now, right away, it says vendor city is invalid, and it's invalid because it's not in our select column clause. So we would have to actually select it to be able to order it.
Does it grab the top 5 first and then order them, or does it order the whole thing and then grab the top 5?
Very good question. It scans the entire table looking for the top 5 based on
And then it
your
orders them.
criteria, huh? And then it orders them, yes. So it scans and builds the result set first and then sorts the result set after it's scanned all that. But that's a really important point that Cohen makes, because if my table has, 2 billion vendors, this could be a really inefficient select statement depending on how the database is set up. We could be really causing a lot of uproar with response time everywhere. Okay, so we've seen lots of things. We can use this top statement to get the top of something. The something we're getting the top of is specified by the order by. Our order by can only use columns that are part of our select statement column list. So some great knowledge. Now, in this example, we're adding the keyword percent to that top statement. And this will do, as you would expect, it's going to scan the entire table, calculating the percentage of what the actual average invoice total is. And then it'll calculate what percentage each of these are of that entire invoice total and give us only the top 5. So it's not displaying to us that percentage. But notice how it changed our output just a little bit. Select top 5 with ties. So what do you think that means?
saying it's okay to select the some that are the same, as it were.
And it wants the ones that are the same, that are tied. So a tie being the same.
So if we switch invoice data or invoice total, whatever, whichever dates are at that, with vendor ID, would that affect the outcome?
On this one? Yeah, try it. You can try it.
Would it affect the outcome?
If there's a top X command, is there a bottom X command?
Yeah, because oftentimes you'll want to know, your customers that have been the least productive and things like that too. So lowest GPA, do it.
So,
Did you try it?
yeah, I had just changed the order. I was
So it's just changing. Yeah, this with ties would be something that would be a very unique situation for you to use that. Be pretty unusual. Okay, so the next thing is specifics about our where clause. Your where clause is an if statement, right? That's all it is. So your where clause is, if this row matches this criteria, add it to the result set so far because it meets the criteria. And just like an if statement in a program, we can compare using the standard comparison operators. This is not. Okay, so greater than, less than, or less than, greater than, I just said it backwards, is not. How many equal signs do you have to do an equal comparison? One.
You're sneaky about it.
Very sneaky.
That's the one thing I hate about SQL the worst is that. Like,
You're so used to doing two. And I was a DVA for so long, it was hard for me to start putting two in. I was like, this is ridiculous. Why would I need two? Now, these examples just give you a whole bunch of different where clauses. Refer to this because there are a lot of great, again, examples in here. Our state is Iowa, where this calculation results in something that's greater than 0, or where the invoice total is greater than the sum of these two numbers. Vendors with names from A to L. And I think you guys have one in your assignment that's somewhat like that. Before a certain date, after a date. And notice the date format can be in a lot of different ways, and SQL will figure out that that's a date. Now they are going to get into not clauses, and again, it's just like if statements. If you use a not clause, it's going to get more confusing. It's going to be harder for people to figure out. We can have compound conditions. So we can use those logical operators like or and in our where clause. So just like an if statement, we can just keep adding and adding and adding to our where clause. The rules are all of the columns that are in our where clause have to be in one of the tables that we're selecting. So those are all pretty standard. That's why it goes well, quickly for you guys. Okay, so we can use parentheses in our where clause also to control the order of operations. And then we have some special cases for our where clause. One of them is the in keyword. So with the in keyword, we can say things like a whole list. So I want to select this terms ID table if the terms ID is in this list, 1, 3, or 4. So that's very, very handy. And then I can do nested selects, and we'll be looking at those in a few chapters. We have between keyword. That's very helpful. Take a look at this slide. It's slide number 38. When we do between, is it inclusive meaning that the boundaries are included in our selection output, or is it not inclusive? I would say it's inclusive, right? Because this between 501 and 531, it would only be logical to assume they're going to get everything for May. So between gives us a huge deal of power, because that would be great if we had if statement capabilities that could use that between keyword. And then some really important stuff, wildcards. Sometimes I want to find something that matches a given pattern in my where clause, so I have the ability to use wildcard symbols. This example uses the like keyword and the %sign wildcard. Notice that the like keyword says it starts like this. So we're going to get any response that starts with SAN and has any number of characters after the SAN. So that'll get us San Diego and Santa Ana. So super powerful. The next example uses the like keyword, and it says like compu underscore ER%. So in the results, notice that we're finding anything that starts with compu, then has a letter. In this case, we have T and E, and then has an ER after that. Now, because we have the % after the ER, it doesn't care about any of the remaining characters. So this is a really powerful query tool, the like keyword. Now, some of you that have had C#2 and you've already done some of those other, I can think what all that stuff is called, you're a lot more familiar with some of these wildcards. This last example says anything that starts with a DAMI then has either an E or an O in the next position, and then an N. Mm-hmm. Yeah, or like if you were doing some sort of scan through textual data and you want to account for different spellings, exactly. Mm-hmm. Now here's some more likes. This is super powerful. You can get whatever you want out of the database with some of these phrases we can use with the where clause. Here we're getting vendor states that start with N and have A through J as the second character. Here we're getting states that start with N but don't have K through Y as the second character. So it's going to get NC and NG, but not Nevada or New York. And in this case, we're getting where zip code is not like a 1 through 9 at the beginning, so we're only getting zeros. So that one shows how confusing we can get things by using a not and then null. When we're using the keyword null, we're using a keyword of something that is unreliable data. Because if it's null, it means we don't know what's there. It's just leftover garbage that's in memory. So it's not something we can use. But we can actually use it in a where clause and say where the invoice total is null or where the invoice total is not null. Have you guys all seen that? All the stuff about that null license plate. Let me read it. It's been all the discussion this week. I don't want to go to Wired because they just give you too much crap. So somebody somewhere set their license plate as null. It was in California. And so it was a computer guy and he thought it would be really funny. And so he asked for the specialized plates and he made them say null. And so then the first year he just got a few tickets that he thought were kind of weird. And then the second year, I think they say he ended up with like $12,000 worth of tickets because every ticket that the police didn't put something in went in as null in the database. And so he got all of those. So anyways, it got him. So null's really important. Don't use that. So I don't know how much it ended up with. I've seen different stories. Some people say it was like $50,000 worth of fines he had and stuff. So
Did you pay them or what
I
happened?
think they figured it out because I think they made him. Well, they say what happened in one story I was reading was that they wouldn't let him choose that license plate again. So he just marked like a checkbox that said, just renew my current plate. So I think the state had already like figured out that it could cause problems. And he got bypassed it because he was just like, yep, I want to keep my current one. And they, okay. And so he kept it and got all these fines. So it can really be a lot of records that are out in the database that have null data. Fun stuff.
I think,
Hmm?
hold on, I need to show something.
Okay.
Do you mind if I share the screen briefly?
No, go ahead.
I know.
What you got? Little Bobby tables. Sanitize your database inputs. Pretty cute. Everybody got it. It's hilarious. Love the database jokes. Okay, let's finish this up so you guys can get them done. Now we can select based on something being 0 or not being 0. Important, we do that a lot. Null and not null. We did an order by clause right away last time, and you guys have figured out that DESC means descending. ASC is the default, so we don't have to specify it, but we can if we want to for ascending. And the default sequence for a sort is pretty important because nulls will actually sort first. So oftentimes that might be the data that they're really not interested in, but it'll go to the top. Then just like any other Ascii character sort, after nulls will be special characters, then numbers, then finally letters. Which letters come first, lowercase or uppercase?
I'm gonna go with lowercase since you didn't say yes.
Exactly.
Yeah, why is lowercase higher?
Well, let's be sure. Let's make sure that we know. I'm going to go to an Ascii code table.
Oh, yeah.
And I could go to that Unicode table, you know, that would be more accurate, but it's huge and I don't like looking at it. So I'll just look at this short one. And so if I look, you guys were right. It's upper. I was messing with you. No, I was wrong. That's why I want to look. So if we're sorting by in ascending sequence, all these things that start with decimal 0 would be like first. So this table is basically sorted in ascending sequence. So we would see all of our special characters, our numbers, and then our uppercase letters, and finally lowercase. You're right on. Now we can use multiple columns in our order by. So in this example, we're going to order first by state, then by city, then by name. So we might want to sort them all. And then our order by can use that as that alias, but we saw that our where clause couldn't. So there are a little bit of differences like that. In this example, we're concatenating the last name and the first name to sort. So we hadn't concatenated those necessarily before, but we can use those in our order by clause that way. And then this one is really ugly and unhelpful. What's going on here?
Ugly unhelpfulness, apparently.
Mhm.
Like 2 and 1.
Yeah, what do they mean with that 2 and 1?
By the second letter and the first letter, maybe?
Moving by the second column, then the first column.
Yep, second column, then the first column.
What?
Yeah, super ugly.
So you
Super
just-
ugly because it's so totally easy to think that it would be anything.
Well, I guess if you have like, you were calling like a million like different rows, that would be useful. If you just forgot to order them the correct way the first time.
If you were like super lazy and didn't want to type that whole column name,
Yeah.
that's good. But so like if you're using SQL within C#, when the data set is returned to you, it actually does name things like this by default. So it'd be column 0, column 1, column 2. So we do get into that kind of messy stuff sometimes when we're going across languages. But yeah, kind of unnecessarily ugly. This one gets,
Does that mean that SQL starts at 1 to 0?
it starts what?
It starts at 1 to 0? There's column there?
Sort of. I'm guessing this column on the far left that has all the numbers in it is the 0 column.
Order by 2, which would be our vendor city. Yeah. And then 1 would be our name. Anaheim blue. Yeah, so it's starting with number 1. And it does do that in a lot of different situations. And we'll see as we get into database normalization where we're designing a database, we don't do repeating things in SQL. So we don't ever have an array in a table because that violates database design rules. So we don't really use an index like that in SQL. But yep, good point. They started it at 1. Now this last example uses an offset. It's going in analyzing the entire table, looking at all of the rows in the table, deciding how many of them are, what does it want? Oh, and then it's ordering it by invoice total descending. And then once that sort is all done, it's starting at the beginning and getting 5 rows. And so here's a place where they start at 0. So it is kind of inconsistent sometimes. Definitely. And then this example does an offset of the first 10 and gets the next 10. So we can jump around and pick different pieces of data out to try things. All right. You know everything about select statements now, more than you wanted to know. Bless you. Because you're amazing database administrators, I want to organize your groups a little different today. But before we do, there's a couple of things. We have almost an hour. I know you guys probably won't need that much time to do all of those select statements. I want you to work with your group and on your own and with your group to create an entity relationship diagram. And you're going to use Visio. And in Visio, there should be a template that you'd want to use. Let's check. Looking at Visio here. Right now, I think I'm on software. This crow's foot database notation looks pretty close, doesn't it? Yep. Let's see what else we've got, if there's any better.
Isn't crow's foot technically the correct one, right?
Yeah, it looks good. That's the one we'd want.
It uses the symbols.
Yeah, it's everything we need.
Model diagram too.
Where? What do you see?
A database model diagram.
Where's them?
I just typed it in the search. That's up top, the search for templates. And then it's just database model.
Because I think this one, this crow's foot one is on.
That
I used.
I'm not sure.
I like that. Yeah, there's lots of options. Now, notice the difference being the arrows. So let's use the crow's foot. They're both perfect. I'm going to create one. And in your Visio diagram, I want you to document 2 tables. So you're going to have an artist table and a, what was the other one I wanted? A band table. So what we're going to do is list for a given artist, we want to know what band they're in. So I'm going to split you guys up. Let's get back in our groups. And I've got some changes here because we made everybody jump around so much last time. Try to make it a little less painful. So table 1 over here is going to be database group 6. We have some people up here, some people not. So we'll see if it works. Then table 2 is going to be design group 1. Table 3 is design group 4. Table 4 is design group 2. Table 5 is group 5 because that's just too easy. And 6 is group 1. So can you guys do this? This is like your first database organization thing.
There's 6 tables, 6 groups.
This is group 1, right?
This is your table 1, and we want group 6 there.
Where's group 1?
Where's group 1? Table 2, right behind you.
Okay.
Because I thought you were sitting in that row. That's why I made that one that your group. Okay, because I was like, because I was trying to get it where people were already sitting. Yes. Try to make it as confusing as I can for my database people. Okay.
So, Ms. Riley, just to be sure we've got this right, I'm going to simplify this for you. This table I'm at now is for group 1, right?
Group 3.
This one is group 3.
Yeah, group 1 is at table 2, of course. Now, with your Visio diagram, I want your group to show me that before you leave, please, so that we can talk about it and make sure that you're right on track before you step out of the room. So I know that it won't take you too long to finish up the exercises for chapter 1. The diagram should be a little bit longer. Yes, you're in the right place. Again, I can give you more.
They put up little stickers actually.
I am in the process of doing that, but Ms. Riley is not telling me a lot.
It's right here.
I'm not 1.
Table 1 is group 6. This table, group 6. Yes, stay there. Zach is absent, so you don't have to worry about him. Noah's going to come over to you, and then Donna is getting everything organized for me. So you're perfect. Table 2 behind you. You guys are all there. Table 3, we have Caleb and Isaac. Table 4, they're all set. Table 5. So Cohen, you guys are at table 6 over here. Sorry, back in the back.
So that's a 6 back there. Okay.
That's all right. You're doing good. We got it. Took us a minute.
So why did nobody cares in general? All you don't have to do in the future is just go to the row that has your group's number on it.
Thank you. Very, very organized. All right. Does anybody not have a database diagram sheet? keep these with you because you know the color prints and all that stuff. It is the one that's online. Save to Canvas.
That answer. And then I just have to add a new query to this section, right?
Yep. Perfect. Thank you, you guys.